Welcome to video 2, which is page 2 of your Unit 5 practice test. We're going to continue on with the same directions from the end of video 1, where we need to classify the quadrilateral, explain the reasoning for that classification, and then find x and y. So let's take a look at question number 5. I can see that all four sides are the same and all four angles are 90 degrees. That is going to make number 5 a square. And your reason there, for 90-degree angles and all sides are congruent. Well, since all sides are congruent, I can take any two and set them equal. So I'm going to take the two of them that have x's, and I'll set those two equal. So 5x minus 4 has to equal 3x. I'll subtract 3x and add 4 to both sides, then divide by 2, so x is equal to 2. Similarly, I can do the same thing over here with the two that are labeled with y's. I can take 5y plus 1 and set it equal to 2y plus 4. Subtract 2y and subtract 1. Divide by 3, and I get y to be 1. A couple of other options you had there. You could have, once you found x to be 2, I could have plugged it in and said 5 times 2 is 10 minus 4. That means this side is 6. Or I could have done 3 times 2 and said this side was 6. Then I could have taken 5y plus 1 and set it equal to 6 and solved for y as well. Number 6, as I look at this picture, I can see that all four sides are the same. And a quadrilateral in which all four sides are the same is called a rhombus. And nice things about a rhombus are the opposite angles are congruent. And as with all parallelograms, consecutive angles are supplementary. So that's actually how I'm going to find the x. I'm going to say that 2x minus 1. If I were to add 127 to that, you'll notice that this angle here, S, and this angle here, T, are consecutive angles. So they have to add up to 180. They have to be supplementary. Okay, combine like terms. So 2x plus 126 equals 180. Subtract 126 from both sides, and you'll get 2x is equal to 54. And then I divide by 2, and I get 27. Now to find y, I can see that 6y minus 5 is the length of SV, and 3y plus 7 is the length of UV, and they're the same, so I can just set them equal. So 6y minus 5 has to equal 3y plus 7. Subtract 3y will give me 3y, and add 5. That's 12. Divide by 3, and I get y to be 4. All right. So that takes care of question number 6. Let me try to move these over, make a little bit of room here. And question number 7. I see it's quadrilateral. I see it has 4 right angles. I don't know anything about the sides, so because it just has right angles, that means that this must be a rectangle. A couple of nice traits about a rectangle is it is a parallelogram. So I have parallels top and bottom. So that means my two angles here that have x listed in them are alternate interior angles. And we know that when we have parallel lines, alternate interior angles are congruent. So that means 5x is going to have to equal 3x plus 18. Subtract 3x gives me 2x is equal to 18, and divide by 2 gives me x to be 9. The other trait to rectangles are the diagonals bisect one another. That's true for all parallelograms. So that means this left part of my diagonal, 2y, and the right part, 10, have to be equal. Divide by 2, and y is equal to 5. Okay, going on. 8, 9, and 10 said find the value of the variable in the trapezoid. Okay, so base angles of trapezoids are congruent, so that's going to really help me find x. That's an easy one now. 50 and x have to be the same, so x is equal to 50. And then y is a same side interior angle to x. So since it's same side interior, it means that it is supplementary. So that means my x value plus my y value has to be 180, because same side interior supplementary. Subtract 50, and y is equal to 130. All right, number 9. We have a mid-segment in there. I know it's a mid-segment because it's connecting the midpoints. And we were told that the mid-segment is equal to half of the sum of the bases. So I take 10 and 18, add them together, and take half of that. So that means x is 10 plus 18 is 28, and half of 28 is 14. Number 10, again, is a trapezoid that shows a mid-segment, so it's the exact same thing. The mid-segment is equal to half of the sum of the other two. So the mid-segment here is 20, and that equals half of the sum of x and 17. Now to get rid of the 1/2, you could distribute. I don't like distributing. I'm going to multiply both sides by 2, actually, to get rid of the 1/2. So if I double the left side, I get 40. When I double the right side, I get rid of the 1/2. So I just have x plus 17. And then I'm going to subtract 17 on both sides. And 40 minus 17 is 23. So x is equal to 23. Another option here would be to find out how far these two things are apart. So to get from 17 to 20, I have to add 3. So that means I'm going to add 3 again to make sure that it is in the middle, that distance is the same. So I could just do 20 plus 3 is 23. It would be a little bit faster of a method to do that one. All right, question number 11 gives us a bunch of information here. So let me, okay. Rhombus JKLM, it is a rhombus. It means all the sides are the same. It says angle LMO. LMO down here is like 30 degrees. OJ is 18. And MK, that whole diagonal is 36 radical 3. Okay, so a couple of things I'm going to do first. First thing I'm going to do, I'm going to label as much of this stuff as I can by its pieces. And by doing that, it'll make finding everything else just a little bit easier. One of the things I know about a rhombus is all of the angles on the interior where the diagonals intersect. They intersect in a perpendicular, so I have 90 degrees on the inside of all of those. I know that the diagonals are angle bisectors. So all of these angles are 30. And then I have these little right triangles that have 90s and 30s, which means that all of the other angles have to be 60. So I have a bunch of 30, 60, 90 triangles. OJ, we said, was 18. So So that means OL is also 18 because diagonals bisect each other. We're told that MK, the whole diagonal, is 36 radical 3. So that means each half would be half of 36 radical 3. Half of 36 radical 3 is 18 radical 3. 18 radical 3. All right. So this is a lot of stuff inside of that little rhombus there. So hopefully you can stay with me here. So now I'm going to start finding my A, B, C, D, and E for this problem. Part A wants to find JOK. So if you just follow from J to O to K, that is an angle in the center there. And we know that the diagonals are perpendicular, so angle JOK has to be 90 degrees. Angle LKO. So if I go from L to K to O, I can see up there in that corner, that one is 30 degrees. MJO, from M to J to O, I can see that one is 60 degrees. The distance from L to J, that entire diagonal from L to J, the two pieces are 18 and 18. 18 plus 18 is 36. And then LK. LK is this little distance over here on the right side, which is the hypotenuse to a 30, 60, 90 triangle. And if you remember, last chapter we talked a lot about 30, 60, 90 triangles. The short side of the triangle across from the 30 is M. Across from the 90 is 2M. And across from the 60 is M radical 3. So 18 is equal to M. M radical 3 is equal to 18 radical 3. So the hypotenuse here has to be twice the short leg. So twice the short leg, twice 18 is 36. 2 times 18 is 36. And the final question on this page, another rhombus, says MO is 4. It's a rhombus, so I know these are right angles. JL, that whole diagonal is 16, so that means each part is 8 apiece. So I have a bunch of right triangles. I don't know if they're 30, 60, 90. I don't know if they're 45, 45, 90. I don't know any of the other angles other than that 90-degree angle in the middle. So L to O, I can see in my picture, is 8. LO has to be the same as OJ. And if JL is 16, then each piece has to be half of that. So half of 16 is 8. KO is going to be the same as MO, so it is also 4. And then KL is the hypotenuse of a right triangle. And I know that all right triangles, a squared plus b squared equals c squared. So I can do 4 squared plus 8 squared is equal to x squared, if KL is x. Okay, so that's 16 plus 64 is equal to x squared. So that means x squared is equal to 80. 64 plus 16 is 80. So that means x is equal to the square root of 80. And I don't like to leave my radicals as the square root of 80. I try to simplify those every chance I get. So if I think about the factor tree for 80, it's 8 times 10, 4 times 2, is 2 times 5, and 4 is 2 times 2. So the square root of 80 is actually the square root of 1, 2, 3, 4 2's and a 5. And to get out of the radical, they must come out in groups of 2. So I can take out a 2 there, take out a 2 there. So the square root of 80 is on the outside, it's 2 times 2, which is 4. inside is a 5. So 4 radical 5. If you just found the decimal for that, the decimal is right around 8.9. It's right around 8.9. So that does it for page 2, and video 3 will contain page 3.